Welcome back again to another BrainFX video. So in this one we are going to look at factorial expressions. So to start with, let's define what a factorial of a number is. So when you say factorial of a number, we mean the product of the positive integers from 1 to that given number. So if you are given a number, let's say that number is represented by a numerical letter n. So if you're given n factorial, what we mean is that n times n minus 1 times n minus 2 times n minus 3, so on and so forth until we reach on what? On 1. So the product of this list of integers is what is denoted as n factorial. Okay, let's take a more practical example. Let's say we have 4 factorial. 4 factorial means 4 times 3 times 2 times 1. In short, all positive integers from 1 to what? To 4. That's what we mean when you say 4 factorial. And this, when you punch it into your calculator, it must give you a value of 4 times 3, that's a 12, and 12 times 2, that's a 24. 24 times 1 is still a 24. So this must be your answer. So that's how we evaluate something or a number with a factorial. Okay, let's try out our first example under factorial expression. Let's say we have 9 factorial divided by 3 factorial. Let's say we have this example. How do we go about finding the value of an expression like this one? So if you have an expression like this one, what you can do is expand the numerator. So 9 factorial can be written as 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And 3 factorial can be written as 3 times 2 times 1. And you can observe that from this point to that point is the same as the denominator. So this part and that can cancel, and you're going to end up with 9 times 8 times 7 times 6 times 5. And this one will give you the value. When you evaluate it, you can just punch it into your calculator and it will give you the value 60480 as your answer. Okay, let's do another example. Let's clear some space and let's clear some space, get rid of these things, and let's say we have a question that says 7 factorial minus 5 factorial divided by 4 factorial. Then we are told to evaluate this particular expression. How do you go about it? Remember, we have a negative there, not a multiplication. So if you are given an expression like this one, you need first to find the value of this part, find the value of this part, and find the value of this part, then evaluate it. Okay, let's do it. 7 factorial, once you punch that into your calculator, you're going to get a 5040, 5040. Minus 5 factorial, that's 120, divided by 4 factorial, that will be 4 times 3 times 2, that will be 24. And when you evaluate 5040 minus 20, you're going to get a 4920 divided by a 24, and this will give you a value of 205 as your answer. So that's how you go about a question like this one. Okay, how about you are given a question that looks like this, or a question that looks like this? How do you evaluate it? I want you to pause the video and think. Okay, so if you are given a question like this one, just know that it has to do with combination. And combination, it's mostly written like this one. And one thing you need to know about combination is that combination corresponds to this expression: n combined r is equals to n factorial divided by n minus r factorial. And we also have what we call permutation, which is denoted as any permutation r, which is equal to n factorial divided by n minus r factorial. These two are what makes up what we call combinatoric or combinatorics. So the two makes up a topic called combinatorics. But in this video, I'm not going to look at on how to apply them. We are going to look at on how to evaluate them. Then I'll make a separate video where I'm going to explain on how to apply them. So meantime, just know how they are expressed as a formula. So now to evaluate this one, let's clear everything and we are going to use this formula. Let's create some space. So we have 7 combined 4. Okay, 7 combined 4. So the question is 7 combined 4. So using the same formula that we have here, we know that n is equals to 7 and r is equals to 4. So this can be written as 7 combined 4, which is equal to 7 factorial divided by 7 minus 4 factorial, 4 factorial. And from this part, we can see that 7 minus 4, it's a 3 factorial multiplied by 4 factorial. Now we can expand. 7 factorial is 7 times 6 times 5 times 4. Now 4, we can write it with a factorial. Reason being is that we can expand this one up to 1. Yeah, this can go on as 4 times 3 times 2 times 1. But this one can be simplified as 4 factorial. So we can write it this way rather than giving a list of values like this one. So we can write it as 4 factorial. Then on the bottom part, let's write it as it is. The reason why I wrote it as 4 factorial, I want to cancel this part and that part, so that I remain with 7 times 6 times 5 divided by 3 factorial, which can be written as 3 times 2 times 1. Now this part will give us 7 times 6 times 5. 6 times 5, that's a 30. And the 30 times 7 is a 210. While 3 times 2, that's a 6. When you divide these two, you're going to get a 35 as your answer. So that's how we go about a question like this one. Okay, let's answer another question that is a little bit complex. than this one. Let's say we have 7 factorial combine, this time let's say combine 5 minus 5 permutation 4. How do you evaluate a question like this one? We know that permutation has an expression that looks like this, over n minus r factorial. And we know that combination has an expression that looks like this, over n minus r factorial r factorial. So we can write this one as 7 factorial divided by 7 minus 5 factorial, 5 factorial, minus, wow, 5 permutation 4 can be written as 5 factorial divided by 5 minus 4 factorial. This part we are going to get a 7 factorial divided by 2 factorial, 5 factorial. Wow, this side we are going to get a 5 factorial divided by 1 factorial. From there now we can combine the two fractions into one, where we can say the denominator will be 5 factorial, 2 factorial, 1 factorial. The numerator, we're going to get this one into that. We'll see that these two parts will cancel. We're going to remain with 1 factorial, which will be multiplied by 7 factorial. Minus this part, we know that this one into this one, the denominator, we're going to get 5 factorial times 2 factorial. And once we multiply this part times the 5 factorial, you're going to get 5 factorial times 2 factorial times another 5 factorial. Then from there now we can find the value of this part, find the value of that part, and find the value of that part. Let's do it. This part can be written as 5 factorial. This part can be written as it is 5 factorial, 2 factorial, 5 factorial, over, we know that 1 factorial is equals to 1. So no need of writing it. We can just write 5 factorial times 2 factorial. And this 5 factorial is equal to 5 factorial is equals to 120. So 120 times 120 times 2, we're going to end up with 2880 divided by, we know that 5 factorial is 120 times 2 factorial is equals to 2. So we're going to get a 240. Okay, let's clear these things and we are going to end up with this part, the numerator part will give us a negative 23760. Are we sure? To give us a 3260. Let me double check my work. Okay, I've noticed the mistake. So there it's a 280 and another 0 at the end. So that we get this as a result, divided by 240. And this one, once you do the math, you end up with negative 99 as your answer. So this is the answer for this expression. Okay, now let's handle a question or an expression without numbers. Yeah, let's do it. Let's say we have a question which says, evaluate this expression. Factorial divided by n minus 2 factorial. So this one, we know that n factorial is equals to n minus, it's n times n minus 1 times n minus 2, so on and so forth, until we reach on 1. So in a case you are given n plus 1 factorial, it's equal to n plus 1. Then this time we're going to say this expression minus 1, we're going to end up with n. Then from there, we're going to have n minus 1. Then from there, we can do the same till we arrive at 1. So this part, we're going to write it as n plus 1, n. Then from there, we're going to have n minus 1. Then from there, we're going to have n minus 2. Okay, let's pause at this point. The bottom part is n minus 2 factorial. And the reason why I decided to pause at this point is because this part and that part can cancel. And we're going to end up with n plus 1 multiplied by n multiplied by n minus 1. And this will be your answer for this particular expression. Very easy, right? Okay, let's do a more complex question. Let's say we are given an expression that looks like this. N plus 3 combine n multiplied by k permutation k minus 1. And we are told that if k is equals to n plus this one, then the question tells us to evaluate this expression. How do we go about it? Remember, we are told that k is equals to n plus 3. So your first step can be replacing k with n plus 3. So where there's k, we put n plus 3. Let's do it. So we're going to end up with n plus 3, combine n, dot. On top where there's k, let's put n plus 3. Then permutation n plus 3 minus 1. And we know that 3 minus 1 is a 2, so we can write a 2 there. Now from there, now we can substitute this with the expression, which is n plus 3 factorial divided by n plus 3 minus n factorial n factorial. Remember, the expression for combination was something like this one. It looked like this. So we need to substitute our given values in accordance with this expression. So from there now, we are going to have n plus 3 factorial divided by this part and that part will cancel. We're going to remain with 3 factorial n factorial. Okay, let's do the same to this side. Let's do the same to this side. Let's create some space. So we know that permutation is equals to n factorial divided by n minus r factorial. So this one can be written as n plus 3 factorial divided by n plus 3 minus n plus 2. Let's put this in brackets. Factorial. And this will result in 2 divided by, it will result into n plus 3 minus n minus 2 factorial. This part and that part will cancel. And 3 minus 2, that's a 1. So we're going to end up with n plus 3 factorial divided by 1 factorial. Okay, So we have this one and we have that one. Let's multiply them. So let's create some space. So this side, in short, the 1 factorial, we can just get rid of it and remain with that one. We know that 1 factorial is equals to 1. So when you create space, let's lab these things. We can say this expression is equal to n plus 3 factorial divided by 3 factorial n factorial multiplied by n plus 3 factorial. Okay, we can lab everything now. Get rid of everything at the bottom so that we finish our question. So from here now we can see one thing, and that thing is that this part and that part are the same, so we can just slide them this way. Okay, let's just slide them the way they are to avoid confusion. Then there we're going to have 3 factorial and factorial and factorial. Now this expression, this part, can be expanded as n plus 3 multiplied by n plus 2 multiplied by n plus 1 multiplied by n factorial. So let's lab this part and write that expression. 1 plus 3 open n plus 2 open n plus 1. Let's lab these things and let's say n factorial. So that part and that part will cancel, and our end product will be this expression. Now the question can go on to say, let's say it says k is equals to, let's say k is equals to 9. Yeah, let's say k is equals to 9. So if you are told that k is equals to 9, then you are told now to find the exact value. Yeah, let me just, so now we have the exact equation here. Hence, find the exact value if k is equals to 9. Okay, so we can lab everything. No, we need this one. Okay, I'll get rid of, okay, let me just copy this part. Okay, I've copied that part just in case we lose it. So we know that this part is as a result of evaluating this one. It's as a result of evaluating this one. But this time we are told that k is equals to 9. So if k was equal to that and k is equals to 9, that will be equal to this, and n will be equal to 9 minus 3, which is a 6. So now we have the values, n is equals to 6, k is equals to 9. Just need now to replace them into that one. So since the expression has no k, we are going to use the n is equals to 6. So we can just say 6 there. We are going to have 6 plus 3. There we put a 6, which will be a 6 plus 3. And they are going to have a 6 plus 2. And they are going to have a 6 plus 1. Divided by a 3 factorial. Now we can get rid of everything on top. Let's get rid of everything on top. So 3 plus 9, that's a 9 factorial. This part, it's a 9 as well. And that part, it's a 8. Then we have a 7. Divided by 3 factorial. We know that 3 factorial it's equal to 6. 9 factorial is equal to that will be 362,880. Now 9 times 8, 9 times 8 it's 72, and 72 times 7, that will give us a 504. Now when you evaluate the numerator, 504 times 362,880, we are going to get a 30 million 4,000. No, we are going to get a 182891520 divided by 6, and once you divide it by 6, you're going to get a 30,000,4,800 you're going to get a 30,481,920 as your final answer. And this one can be read as 30,481,920. So that will be your answer when you evaluate this expression, and if k is equals to n plus 3, where k is equals to 9. Okay, that's it for this video. See you in the next video.